double angle, half angle, and product sum formulas. We have the following double angle formulas for sine, cosine, and tangent. One thing to notice is that cosine has three formulas. Now, all three of these formulas are the same, and they basically come from using the Pythagorean identity into the first one here, and you can get the other two. But fundamentally, these formulas all come from the sum and difference formulas, which I am not covering in this video series. These formulas allow you to find the sine, cosine, or tangent of 2 times an angle by only knowing about the sine, cosine, or tangent of the original angle. Let's take a look at some examples. If cosine of x equals negative 2/3 and x is in quadrant 2, we want to find the cosine of 2x and the sine of 2x. So for the cosine of 2x, recall that there are three formulas. We have cosine squared of x minus sine squared of x. We have 2 cosine squared of x minus 1, and we also have 1 minus 2 sine squared of x. Now you can use any of these three formulas, but take into account that we only know about the cosine of x, right? We don't know about sine of x. So it would be wise to use the second formula. So if we do that, the cosine of 2x is going to be 2 times cosine squared of x minus 1. So I just need to plug in what is the cosine of x here, and that is negative 2/3. Now if we do the math here, we have 2 times 4/9 minus 1. This is 8/9 minus 1, which is 9/9, and this gives us a result of negative 1/9. Now we could have used either of these other two formulas, but to use these, we would have had to know what the sine of x is. Now, to find the sine of 2x, we're going to use that formula, which is 2 sine of x cosine of x. And to get this, we will need to finally know what is the sine of x. So we know the cosine of x is negative 2/3, and we know the angle x is in quadrant 2. We can draw a picture of that. So here is an angle in the second quadrant. That angle is x, and the cosine is negative 2/3, which by the definition is x over r. Or I shouldn't say x because x is the angle. It's the adjacent side divided by the hypotenuse. And then we can find the missing side here by using the Pythagorean identity. And I'll skip the work on this, but this is going to end up being the square root of 5. And now you can see that the sine of this angle is radical 5 over 3. So now we can find the sine of 2x by multiplying 2 times the sine of x, which is radical 5 over 3, times the cosine of x, which is negative 2/3. And if we do the math here, 2 times radical 5 times negative 2 is negative 4 radical 5, over 3 times 3 is 9. So here we have the cosine of 2x and the sine of 2x. Now, just to be clear, if we had done this first, we could have used these other two identities to find the cosine of 2x. Let me just show you what that would look like. So cosine of 2x, if I choose to use the first identity here, would be cosine squared of x, so that would be negative 2/3 squared, minus sine squared of x, which would be radical 5 over 3 squared. And this would be 4/9 minus 5/9, which is negative 1/9. So you see you get the same answer as we got before. And of course, if you use this formula, you would get the same thing. Now this next example is more just an algebraic exercise. We want to write cosine of 3x in terms of cosine of x. And there's a little bit of a trick here. The first thing I'm going to do here is I'm going to change cosine of 3x to be the cosine of x plus 2x, right? Because x plus 2x is 3x. From there, we can use the sum formula for cosine. which again, I am not covering here in this video. But the formula is cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Now from here, we're going to rewrite this as cosine of x multiplied by cosine of 2x. Now cosine of 2x, remember, there are three formulas for that. But they want us to write our final answer in terms of cosine only. So I'm going to choose to rewrite cosine of 2x as 2 cosine squared of x minus 1. Then we have minus sine of x multiplied by sine of 2x, which is 2 sine x cosine x. Let's do a little multiplying now. We have cosine of x times 2 cosine squared, that is 2 cosine cubed of x. Cosine of x times negative 1 is negative cosine of x. Minus 2 times sine is 2 sine squared x times cosine x. Okay, so we've written everything in terms of cosine except for this sine squared right here. But let's remember from the Pythagorean identity, sine squared is equal to 1 minus cosine squared. So if we make a little substitution here, and then multiply everything out. So here we have negative 2 times 1 times cosine. That's going to be negative 2 cosine. And then we have negative 2 times negative cosine squared times cosine. That's positive 2 cosine cubed. And of course, we still have these terms here. Combining like terms, we have 4 cosine cubed minus 3 cosine of x. And we have successfully written cosine of 3x exclusively in terms of cosine of x. And again, this is more just an algebraic exercise more than anything else. So this next proof is another example of an algebraic exercise. We would like to prove that the left-hand side here is equal to the right-hand side. Notice that on the right-hand side, we only have x's, but on the left-hand side, we have a 3x. So I'm going to employ the same strategy as in the last problem. So on the left-hand side, sine of 3x can be written as the sine of x plus 2x. And then we have sine x cosine x, which is just going to hang around in the denominator. Sine of x plus 2x is going to be sine of x cosine of 2x plus sine of 2x cosine of x. And this is the formula, the sine of a plus b. And again, I did not cover this in this video, nor am I planning to cover this in this video series, but most students have learned this in a trigonometry class. This is over sine of x cosine of x. Now what we're going to do is simplify these. So sine of 2x, of course, is 2 sine x cosine x. And then cosine of 2x, we kind of have a decision to make. Should we write this in terms of sine alone, cosine alone, or sines and cosines? Well, in this case, since we kind of have sines and cosines all over the place, I'm going to choose to write cosine of 2x as cosine squared x minus sine squared x. Now, if I'm wrong, we can always go back and change it. So we have sine of x times cosine squared x minus sine squared x plus sine of 2x, which is 2 sine x cosine x, times cosine x. Doing the math here, don't forget the denominator. Now doing the math, we have sine times cosine squared minus sine times sine squared, which is sine cubed, and then plus 2 sine x cosine squared x, all divided by sine x cosine x. Okay, it's getting a little messy, but one thing you should see is that we have a sine of x in all three terms. So we can factor out a sine of x, and then we'll have cosine squared minus sine squared plus 2 cosine squared, all divided by sine x cosine x. Now, the sine x here cancels out. And now notice in the numerator, all we have left here is a cosine, and then we have this single sine here. It's a sine squared, actually. And then we have a cosine in the bottom. If this were a cosine, that seems like that would be a good thing. But let's go ahead and see what else we can do here. Cosine squared plus 2 cosine squared is 3 cosine squared. And then minus sine squared. And then over cosine of x. And let's take a peek. It's okay to look to see where you want to end up. Okay? So if you notice here, we want to end up getting this expression. All right, so what can we do here? Well, it seems like at this point we should probably change sine squared of x into 1 minus cosine squared of x. So let's go ahead and do that. We have 3 cosine squared of x minus the quantity 1 minus cosine squared of x, all divided by cosine of x. Let's see what we have now. We have, do the math here, 3 cosine squared minus 1, and then you're going to have plus cosine squared. So 3 cosine squared plus cosine squared is 4 cosine squared minus 1. And then it's over cosine, which means over cosine here and over cosine here. And if you notice, this cosine will cancel out one of those, and that's 4 cosine. And then 1 over cosine, we know that this is equal to secant. And just like that, we get what we wanted, right? That's what we wanted. So we've proven that this is true. Next, we have some formulas for lowering powers of sines and cosines and tangents. Now, these formulas here, just to be clear, come from the double angle formulas that we just looked at a moment ago. So if you solve for sine squared and cosine squared in the double angle formula for cosine, you will get the first two. So we can use this to do things like lower the power of sine and cosine. So for example, express sine squared times cosine squared in terms of the first power of cosine. So what we can do here is we can say, well, sine squared is equal to this. So 1 minus cosine of 2x divided by 2. And that's multiplied by cosine squared, which is equal to this. So 1 plus cosine of 2x divided by 2. Now, if we multiply these out, in the bottom here, we have 2 times 2, which is 4. On top, we have 1 times 1, which is 1. And then 1 times cosine and negative cosine times 1, and those are both cosine of 2x. Those are going to cancel out. You're going to have a positive cosine of 2x and a negative cosine of 2x. And then finally, negative cosine times cosine is going to be positive cosine squared of 2x. And so these cancel, and we end up with 1 plus cosine squared of 2x all over 4. Now we can rewrite this as 1/4 times 1 plus cosine squared of 2x. Now, what I'm trying to do is write everything in terms of the first power of cosine. Well, I do only have cosine, but it's not a first power, it's a second power. So I'm going to apply these formulas again. Now, the formula says cosine squared of x is equal to 1 plus cosine of 2x. So if I have a 2x here, then this would just be a 4x. So the relationship is this angle over here needs to be double what the angle is here, okay? So this cosine squared of 2x down here is going to be replaced. So we have 1/4, 1 plus, and then cosine squared of 2x is going to be 1 plus cosine of 4x divided by 2. And now we just need to work this out. So we have 1/4 times 1 plus 1/2 plus 1/2 cosine of 4x. So when I divide each of these by 2, I just get a 1/2 in front. And now we have 1/4. 1 plus 1/2 is 3/2 plus 1/2 cosine of 4x. And we could stop here, but I'm going to distribute and write this as 3/8 plus 1/8 cosine of 4x. And now we have successfully written it in terms of the first power of cosine. Now it's okay that we have the 4x here. They didn't say anything about that. We just want cosine to be raised to the first power, and we've accomplished that. And by the way, this is something that is very useful in calculus. Next, we have our half-angle formulas. These half-angle formulas actually come directly from the power reduction formulas on the previous page. Now, for the sine and cosine half-angle formulas, you do have a plus or a minus in front. It's not plus and minus. It's you have to choose the correct one depending on the quadrant that u over 2 is in. So, for example, if I want to find the sine of 22.5 degrees, we're going to recognize that 22.5 is the same as 45 divided by 2. So that's the sine of 45 degrees divided by 2. So if you look at your formula here, u is equal to 45 degrees. And so according to the formula, this is going to be plus or minus, and we have to choose the right one, square root of 1 minus the cosine of u, which is 45 degrees, divided by 2. Now, this is going to be positive because 22.5 degrees obviously is in quadrant 1, and everything is positive in quadrant 1. So this ends up being the square root of 1 minus radical 2 over 2 divided by 2. And now we just have to simplify. The easiest way to simplify here is just to multiply the top and bottom here by 2. So that's going to give us a square root. We're going to have 2 times 1, which is 2, minus 2 times radical 2 over 2 is radical 2, over 2 times 2 is 4, and that will be the square root of 2 minus radical 2 divided by the square root of 4, which is the square root of 2 minus radical 2 over 2, which is an interesting answer. So for the next one, we want to find the tangent of u divided by 2 if the sine of u is equal to 2/5 and u is in quadrant 2. So let's bring in the tangent formula. And notice that to do this correctly, no matter which of these two formulas you choose to use, you do need to know the sine of u and you need to know the cosine of u. So they told us that sine of u is 2/5 and u is in quadrant 2. Let's draw a picture of that. So here is an angle in the second quadrant. Okay, that will be u. And we know sine is 2/5. And then we can find the missing side here by using the Pythagorean theorem. That's going to be the square root of 21. And it's going to be negative because we are in the second quadrant. And now because of that, we can see that the cosine of u is negative radical 21 over 5. So now, again, it doesn't matter which one of these you choose to use here, but I'm going to use the first one because I just like the denominator a little better. It's a little simpler. So the tangent of u divided by 2 in this case is 1 minus cosine of u divided by sine of u. And this is equal to 1 minus negative square root of 21 over 5 divided by sine of u, which is 2/5. And then I'm just going to multiply the top and bottom here by 5. And so that will give us 5 times 1 is 5 plus, right, minus is plus. The 5's here cancel out and we get radical 21. And then in the denominator, we just get 2. Next, let's talk about simplifying an expression involving an inverse trig function. Now, in this case, we have sine of 2 inverse cosine of x. The main thing to remember is anytime you have an inverse trig function, this is always equal to an angle. So let me give that angle a name. Let me call it theta. So if I call theta inverse cosine of x, then this expression basically just turns into the sine of 2 theta. And we know the sine of 2 theta is 2 sine theta cosine theta. So all we need to figure out is what is the sine of theta and what is the cosine of theta. And if we plug those in, we'll have our answer. Well, now let's draw a picture of what does it look like if theta equals inverse cosine of x. Well, remember, this means that cosine of theta is equal to x, which is x over 1. And we can draw this picture in the first quadrant. So here is our angle theta. Cosine is adjacent over hypotenuse. This side here, according to the Pythagorean theorem, will be the square root of 1 minus x squared. And that means the sine of theta will be the square root of 1 minus x squared over 1, which is the square root of 1 minus x squared. And again, we already know the cosine of theta is just x. So this becomes the square root of 1 minus x squared, and this becomes x. And then we can rewrite our final answer like this. So when it comes to writing these kinds of expressions in terms of x only, it might seem a little daunting at first. Always go back to the basics and ask yourself, what is an inverse trig function? Remember that it's just an angle, right? And then as soon as you give that angle a new name, when you call it theta, all of a sudden now it turns into something that you recognize. And then you can apply your double angle formulas. So in the next example, this is pretty much the same thing. They want us to evaluate the sine of 2 theta when we know that cosine of theta is negative 2/5 and theta is in the second quadrant. So again, if they want us to evaluate sine of 2 theta, we're just going to remind ourselves that sine of 2 theta is 2 sine theta cosine theta. So that's going to be 2 times whatever sine theta is multiplied by whatever cosine theta is. Now they tell us cosine theta is negative 2/5, so we can go ahead and put that in. But then we don't know what sine of theta is, right? That's the question. But again, we know that theta is in the second quadrant. So here's theta. And we know that cosine of theta is negative 2 over 5. So we can find the missing side here. This is going to be radical 21 according to the Pythagorean theorem. And now we know that sine of theta is radical 21 over 5. And so now we can put that in here. And this is going to give us negative 4 square root of 21 over 25. So it's really very much the same as what we did in the previous example, but it just sounds a little different in the way that they state the problem. Now our final 2 examples deal with the product to sum formulas and then the sum to product formulas. And these formulas are really complicated, and most professors will not ask you to memorize these formulas. I certainly don't in my classes. And so let's go ahead and just accept that these are true. We could prove these. I won't do that here. But basically, these are useful in taking the product of a sine and a cosine, or a cosine and a cosine, or a sine and a sine, for example, and changing it into a sum of a sine and or a cosine. So for example here, if I want to express sine of 3x times the sine of 5x as the sum of trigonometric functions, what I'm doing is I'm taking the product of 2 sine functions and I'm changing it into a sum. And that's why this is called product to sum. Now the formula we're going to use for this is the last one. And we're going to use this formula with u equals 3x and v equals 5x, right? Because this is u and this is v. So the sine of 3x, sine of 5x, according to this formula, is 1/2 times the quantity, cosine of 3x minus 5x, minus cosine of 3x plus 5x. Now we just need to do a little simplifying here. So we have 1/2 cosine of negative 2x minus cosine of 8x. Now, one final thing we can do here is just recall that cosine is an even function. So the cosine of negative 2x is the same as the cosine of 2x. And we can leave our answer like this, or if you want, you can distribute the 1/2, in which case you get this answer. And one final comment here, you don't actually have to have parentheses around the 2x or the 8x. So the final answer looks best, I think, if you read it like this. And then we have the reverse of this process. So this is when you can take a sum of two trig functions and turn it into a product. And you can see the various formulas. And once again, I don't require my students to memorize these, but if you have the formula sitting in front of you, you definitely should be able to utilize the formula. So I want to write the sine of 7x plus the sine of 3x as a product. So the formula I'm going to use, of course, is the first one. Sine of x plus sine of y. In this case, x is actually 7x, right? And y is actually 3x. So we're going to use this formula, but this will be 7x and this will be 3x. And so the sine of 7x plus the sine of 3x is equal to 2 times the sine of 7x plus 3x divided by 2 times the cosine of 7x minus 3x divided by 2. And then we'll just simplify. So 7x plus 3x is 10x. 10x divided by 2 is 5x. And then we have cosine of 7x minus 3x is 4x divided by 2 is 2x. And that is as far as we need to take this one. And again, you can see now we have changed a sum into a product. And that concludes this video lesson.